Okay, good morning everyone. Welcome to the Math 1301 College Algebra Final Exam Review. My name is Dr. Radel. Dr. Quander is in the back at the sign-in table. For the next 3 hours, we'll be taking you through the Final Exam Review. I know it's quite daunting. You see all those 100 or so questions on the review. We'll get through most of them today. We've carefully picked out what we feel are the most important questions on the review, and we'll actually go through most of those 100 with you. I'll spend the first hour and a half going through the first half of the review. That'll take us through about 10 o'clock, and then Dr. Quander will take over and take you through the rest of the review, the second half. If you have any questions as we're going through, please feel free to interrupt us. Raise your hand, let us know if you have a question, and we'll be happy to answer them for you. You should have a copy of the final exam review sheet with you so that you can follow along. We may have extra copies in the back if you need one. Also, just a couple of announcements. The Math Lab in 925 North is open all this week and next week if you need additional help. The online version of the final exam is tomorrow. Remember, tomorrow morning. If you signed up, please remember what room you're scheduled to go to. Arrive at around 8:45 in the morning, and the exam will begin at 9 a.m. There may still be some spots available, and so if you haven't yet signed up for the online version of the final, you can go to 925 North after this session and sign up. Also, if you score 100% on the online version of the final, you'll be entered into a drawing to win a $150 book voucher that you can use next semester. So additional incentive to do well on the online final exam. Also, remember that there is a practice final exam in my math lab. You can go there and practice, see some questions that are going to be similar to questions you'll see on the final exam. And remember, your written final exam is all multiple choice, whereas the online version of the final exam is not all multiple choice. Both exams have 40 questions, roughly 3 hours or 2.5 hours for the exam. Okay? And usually, if you take both exams, your instructor will count the higher of the two exams. Okay? So I'm really glad you're all here. It's nice to see a big crowd. Let's get started. Okay. In this course, the very first thing that you learned was how to classify numbers. Once we have a number, we can classify it as belonging to one or several different categories. And so here we have some examples in number one. We want to look at natural numbers, integers, rational numbers, and real numbers. And let's just quickly review what these types of numbers are, or define these numbers. Natural numbers, the positive whole numbers, right? Numbers like the counting numbers, 1, 2, 3, 4, 5, etc. Positive whole numbers are natural numbers. Integers, well, if you take all of the positive whole numbers together with their negatives and also throw in 0, you have the set of integers. Okay, so all natural numbers are also integers, but not all integers are natural numbers. Not all integers are positive whole numbers. Rational numbers, think ratio or fraction. A rational number is any number that can be expressed as a ratio or as a fraction of integers, integer over integer. And all numbers that are not complex numbers are real numbers. Okay. And so here in part A, we have the square root of 9, which is also equal to what? 3. Good. And so 3, well, 3 is a positive whole number, so it's a natural number. It's also an integer. 3 can also be written as 3 over 1. So 3 is a rational number. And is 3 a real number? Of course. Right. So notice that the square root of 9 satisfies all 4 of those categories. Okay. The square root of 2, however, is square root of 2 a natural number? No. It is not a positive whole number. The square root of 2, is it an integer? It's not an integer either. However, is it a rational number? Can I write the square root of 2 as a ratio of integers? Don't think so, right? And so we say that square root of 2 is not a rational number, but it is a real number. The only square roots that are rational numbers, actually are natural numbers as well, is if the number under the radical sign is a perfect square. For example, when we had the square root of 9, 9 is a perfect square, so the square root is 3. That number is natural, integer, rational, and real. But the square root of a number that is not a perfect square is not a natural number or an integer or rational. It's a number that we call irrational. Okay? It's a real number, though. 22 over 7, well, there you see a fraction of integers. Now, 22 over 7 is not a whole number. It's not a natural number. It's not an integer either. However, it being a fraction, it is rational, 22 over 7. And it is also a real number. Okay. 22 over 7 is actually a pretty good approximation for an irrational number called pi. Okay. It's approximately 3.14. What about negative 10? The last one here, negative 10. Is it a natural number? No, it's got to be positive whole number to be a natural number. Is it an integer? Yes, it is. Is it a rational number? It is, because I can write negative 10 as negative 10 over 1. So it is rational. Is it real? Yeah. Okay, so it's real. All right, so classifying numbers. All right, looking at number 2 here, we want to describe in part A the population of a town. And so we want to think, what's the best way to do that? Well, if we're describing a population of a town, we're talking about positive whole numbers. You can't have a fraction of a person. Okay, now I know there's such things as half-brothers and half-sisters. That's not what I'm talking about here. Right. So a population of a town, we've got a positive whole number here. And so the best way to describe that would be using a natural number, like 5,250,000 would be a population of a town, a pretty large city. And it says there's only one correct answer for each part. While a natural number is also an integer, it's also a rational number, it's also a real number, the best way to describe the population is using a natural number. What about measuring gallons of gasoline? And when you go fill up your tank with gas, do you always put a whole number of gallons? Not always, right? Sometimes that number has a decimal. And so the best way to express gallons of gasoline, I don't think natural number would be the best way to do it. Integer, no, not really, and you'd never have negative number of gallons of gas, so there's no importance of having integers. Rational number, I think, appears to be the best one there. Okay. Each of you should have a copy of the formula sheet that was handed out up at the sign-in table. You can always grab one on your way out if you don't have one. But in looking at number 3, the way to solve this is a percent change problem in number 3. And here we need to remember the formula for calculating percent change. Okay. If we have a change from a value C1 to C2, percent change, the formula, I'll write it down for you here, is C2 minus C1 divided by C1 times 100%. And so the question here says find the percent change in the enrollment at Texas Southern University from 2003 to 2007. Okay? And we have this table of data here. X represents the number of years after 2000. So X equals 3 represents 2003. And X equals 7 represents 2007. Okay? And we're interested in these values here, 10.9 and 9.5. Those numbers represent the enrollment in thousands of students, okay, in 2003 and 2007, respectively. And we're trying to find the percent change from 2003. Okay, so 10.9, we're going to call that our C1. 9.5, we're going to call that our C2, and we're going to take C2 minus C1, divided by C1 times 100. Okay. You are not going to be given the formulas on the exam. You need to know the formulas in advance. Okay. You need to have those memorized. All right. And so here, when we calculate this, we get negative 1.4 divided by 10.9, which is negative 0.128, and we have to multiply by 100%, and we get negative 12.8%. Negative 12.8%. So we have to remember at the end to multiply by 100. Okay, if we had forgotten to multiply by 100, we may have guessed B and we'd be incorrect. Okay. Notice that answer A is incorrect. The change in the enrollment was negative 1.4. Well, we had negative 1.4 here in the calculation, but that gives the amount of change, not the percent change. So the answer here is C. Whenever we have a negative answer for percent change, we're talking about a decrease. And that's what we have. The enrollment decreased from 10.9 to 9.5. Okay, so percent change, we have to use the formula to calculate percent change. Okay, number 4 is more of a concept question rather than anything we need to work out. We're given 3 graphs, and we want to see which of the following graphs are graphs of functions. Okay, so let's just go down the line. Remember that a function is defined for every x value input, there's exactly one y value output. Okay? We also have a test called the vertical line test that helps us determine whether we have the graph of a function. Is graph 1 the graph of a function? Yes, it is. What about graph 2? Yes, it is. In fact, that's the graph of a constant function because the graph is a horizontal line. What about graph 3, that oval? No. We fail the vertical line test there, right? In fact, we see that there are several x values that have multiple y values. For example, when x is equal to 0, y is equal to 3 and also negative 3. You can't have that for a function. And so which of the following is the correct answer here? A, B, C, D, or E? Looks like D. Okay? Looks like D. So nothing really to work out there. You just have to know what a graph of a function looks like. All right, now we've got a midpoint question. Okay, there's a midpoint formula. If you have 2 points given, say x1, y1, and x2, y2, we have a midpoint formula. The coordinates of the midpoint of the line segment connecting these 2 points is given by, well, the x-coordinate is given by the average of the x-coordinates, and the y-coordinate of the midpoint is given by the average of the y-coordinates. So add up the x values, divide by 2, add up the y values, divide by 2. For the x-coordinate, we have 6 plus a negative 4 divided by 2. So that's 2 over 2, which is 1. So the x value of the midpoint is 1. Now looking at this list of answers here, the only answer I see that has x equals 1 is A, but notice answer choice E is none of these, so we do have to work it out because maybe the answer would be E. So let's take a look at the y-coordinate. For the y-coordinate, we add up the y values, 3 plus negative 7, and we divide by 2. That's negative 4 over 2, or negative 2. So indeed, A is the correct answer. The x value is 1. The y value is negative 2. Okay. The midpoint formula gets you the coordinates of the midpoint. Don't try to graph and guess. Use the midpoint formula. Question 6 is kind of similar to question 4. We don't give you graphs here, but rather give you a table of data or several tables of data and ask you to find out which of the following relations are functions. Okay, remember, a function, for every x, there's exactly one y. So is number 1 here a function? It sure is, yeah. What about number 2? No, we see here that we have 0, 2, and we have 0, 5. See, functions are very predictable. For every x, we know exactly what the y is going to be, and there's only going to be one y. Here, for x equals 0, is it 2 or is it 5, right? You shouldn't be given two different y values if you have only one x value. So 2 is not a function. What about 3? I hear no, I hear yes, I hear ness, I hear yo. Okay. The answer is yes. This is a function. This is a constant function. Okay. It's a constant function. No matter what x value you have, the y value is always the same. It's okay to have different x's go to the same y. Right? X squared is an example of that, right? You have negative 3 squared is 9 and 3 squared is 9. The different x's can go to the same y, but you can't have the same x go to different y's. Okay, so number 3 is okay. What about 4? 0 goes to 10, 1 goes to 8, 2 goes to 7. 2 goes to 7. Right? We're not getting anything wrong there, so 4 is okay. 4 is a function as well. Okay, they just listed the data point twice. Okay. All right. I'm sorry?
It's going to the same y value, that's why.
The same x value here going to the same y value, so it's okay. Right? In number 2 here, that was not okay. We had the same x going to two different y's. That's bad for a function. One thing you'll definitely be asked on the final exam is a question about domain. Okay. What is the domain of the function? We're going to look at a couple of domain problems here. For the first one, we see something called a rational function, where we have a fraction. And whenever you're trying to find the domain of a rational function, what do you look at in the rational function? Look at the bottom. Yeah, look at the denominator. Right? And what could go wrong is if the denominator evaluates to 0. Right? Any value of x for which the denominator would evaluate to 0, that value of x, we say, is not in the domain of the function. The domain consists of all real numbers except those x that make denominator 0. So what we can do is we can take this denominator, set it equal to 0, and solve it for x. Those values of x are not in our domain. So we have 2x minus 1 equals 0. In other words, by adding 1 to both sides, we have 2x equals 1. Divide both sides by 2, and we get x equals 1/2. And that value is not in the domain. So we would answer this question, or we would choose the answer that says the domain is all real numbers except x equals 1/2. That's our domain. Okay. So it's easier to find out which numbers are not in your domain here, and then the domain is all real numbers but those. Okay. Notice we don't have to look at the numerator. Who cares about the numerator? Right? The denominator, we don't want it to be 0. Okay? You get complete garbage if you have denominator 0. Okay? Now another interesting domain problem occurs if the function is involving square roots. Okay? Now in terms of real numbers, you cannot take the square root of a negative number. Okay? If you take the square root of a negative number, you end up in the world of complex numbers, which you've learned about. Right? But for domain problems, we're only concerned about real numbers, getting real numbers as answers. And so we look at what we see under the radical sign, under the square root symbol, x minus 6. In order for a number to be in the domain of this function, okay, the function must evaluate to something where that what we have under the square root must be either positive or 0. It can't be negative. Okay? So the domain would be all x for which what we have under the radical symbol turns out to be not negative, greater than or equal to 0. So here we have an inequality, and by solving this inequality, we'll get what values of x are in the domain. Okay, so what can I do to both sides of this inequality to solve it for x? Add 6. Does that change the symbol at all? Nope. Okay. So x greater than or equal to 6 is the domain for this function. And where is that? That's A. Okay. Greater than or equal to is the question?
Why is the sign different?
We want all values of x so that what's under the radical sign is either positive or equal to 0. We don't want negative. Okay? So the domain is now all numbers x greater than or equal to 6. And if you're not sure, right, just try some. Right? What if x were 9? Then you'd have the square root of 9 minus 6, the square root of 3. Well, that's defined. Right? That's a number. Okay? But what if, say, x were equal to 0, a number that was not greater than or equal to 6? Then you'd have the square root of 0 minus 6, the square root of negative 6, which is not a real number. Right? It's an imaginary number. Okay? So only x greater than or equal to 6 satisfy. And looking at number 9, right, the domain there, again we have a rational function here. This one's similar to the last one, or number 7, in that we look at the denominator. Right? Looking at the denominator, we do not want the denominator to be equal to 0. So what numbers would not be in our domain? In other words, what numbers x would make the denominator equal to 0? 6 and 2. Yeah. So not in the domain, x equals 6, x equals 2. So the domain would be all real numbers except x equals 6 and x equals 2. Okay. Any other number for x would give you an answer. Yes?
Is there a way of writing out all real numbers except 6 and 2 mathematically that will appear as an answer choice on our exam?
Just like this.
Okay.
This is how you would see it. And the last one involving domain, here we have a polynomial, a quadratic polynomial, degree 2, x squared minus 2x minus 3. Okay, notice it's not a rational function. I don't see any radicals anywhere. Okay? And so the domain of a polynomial, right, think about all the possible x that can be plugged in, all the possible values you can plug in for x and get an answer. Okay? Are there any numbers that are not in the domain here? What would they be? Not in the domain. If I plug in 3, looks like I'm going to get 0, but that's okay, that's an answer, as long as it's not in the denominator. All real numbers. Right? I could plug in any number at all and get an answer. So the domain here is simply all real numbers. If you see a polynomial, the domain is all real numbers. Polynomials are defined for all values of x. All right, let's look at number 11. We have a graph. Whoops. And on this graph, we want to find the domain and range of this function. Okay? Now, what we have are 3 points plotted here, 0, -1, 1, -2, 3, 5. And we want to find the domain. Okay? So, given a graph, and notice that there are endpoints of this graph, in thinking about the domain, think about x values. Okay? The domain is x. The range is y, okay, or f of x. And for the domain, we'd like to think about the smallest value of x that you see here, and also the largest value of x here. What's the smallest value of x that we see here? 0. And what's the largest value of x? 3. Okay? So our domain is going to go from 0 to 3. Okay? Now, the only answer choices that involve a domain going from 0 to 3 are A and B. Okay, so we've already narrowed down our answer choices to 2 choices. This is a multiple choice test that you're going to be taking, so try to do this. Look at your answers and see which ones you can eliminate. Okay. Now we think about the range. Now the range involves y values. Okay. What is the smallest y value that you see on this graph? -2. -2 is smaller than -1. In terms of a graph, what's the lowest point you see? Right? The lowest is the smallest y value, and that's -2 right here. And the largest y value that you see? 5. So what's the correct answer? B. The range goes from -2 to 5. Okay? Don't be tricked into saying choice A. A is not correct. because -1 to 5, well, you're leaving out some elements of the range. You're leaving out -2, for example. Okay? So think smallest x, largest x, smallest y, largest y, okay? When you see a graph. All right. I think we've got the same graph here, but now we're asked to do different things. And now we're asked to evaluate a function by looking at its graph. So there's nothing to plug in here. All right, there's nothing to plug in, but rather look at a graph and determine the value of the function. So let's see what I can fit on here. F of 0, remember, the input is the x, and the output is the y. So when x is 0, what's the value of y? -1. Right? Not too hard. And when x is equal to 1, what's the value of y? So f of 1 is -2. What would therefore be the value of f of 2?
0.
Yeah, this point here, it's not labeled, but you see it. It's 2, 0. Okay? And so when x is 2, f of 2, or y, is 0. And then what's f of 3? F of 3 is 5. Okay? So just looking at a graph, find the corresponding point. You know a point on a graph has an x value followed by a y value, or f of x value. Question 13 we're not going to go over because it's pretty much the same concept as question 12. Okay, so we're not going to go over all of these, but the concept is repeated, so I'll skip over 13. All right, now looking to evaluate a function. Given some function, for example, this one here, f of x equals 3x plus 5, the input is x. Okay, so whatever we're asked to evaluate the function at, that's what we plug in for x. So if I said what's f of 3, you would plug in 3 for x. If I said what's f of 0, you'd plug in 0 for x. The number that you plug in doesn't actually have to be a number. It can be an expression. For example, here we want to evaluate f of a minus 1. Okay? So the trick is the same. You take a minus 1 and you plug it in for x. So you plug in a minus 1 everywhere you see an x in the function. So f of a minus 1 is going to be, well, our function is 3x plus 5. So we have 3, but instead of writing x, I write a minus 1. Okay. And then simplify this, distribute the 3 through the parentheses. 3a minus 3 plus 5. And then gather the like terms. We have 3a, and then minus 3 plus 5 is plus 2. So our answer is C. Okay. You're going to see a bunch of other incorrect answers that are put there to distract you or try to trick you. Okay. Don't be tricked. I know you won't be tricked. Okay. You're going to get the right answer. You're going to circle it and then move on to the next one. Okay. Just be real careful. Watch your signs. Okay. These detractor answers have been carefully chosen to try to trick you. Okay. Don't fall for the tricks. Number 15 is a concept question. Okay. And it's actually not a very difficult question if we just remember function notation. Q of something equals something. Q of negative 2.5 equals 3.2. Q is the name of the function. What's the value of x here? And the value of y? 3.2. If you remember that, you're golden, because you remember that the point that lies on the graph of Q must therefore be x, y. Negative 2.5 comma 3.2. Okay. Not too bad. All right, thinking about function interpretation now. All right, so we've got a little word problem here. So we want to read it carefully. It says, for a person that's x inches tall with a sprained ankle, the length of crutches in inches that he or she may need is approximated by this function. It's a function of x. X is the input. Y, or f of x, is the output. So we should look at a function and think about what does x represent and what does the output y, or f of x, represent. And so here we're told that the person is x inches tall. So the number that we're going to be putting in for x is going to represent the height of the person. X is going to be the height of the person in inches. And what does y, or the output, represent?
The
the length of the crutches. Okay, so the length of the crutches, that's f of x or y. That's the output. Okay, so given some height of a person, we plug that number in and get the length of the crutches that that person should have if they are laid up with a sprained ankle. So here's our function, and we want to evaluate and interpret f of 75. Okay, so first let's evaluate it. F of 75 means x is equal to 75, which means that the person is 75 inches tall. Okay, that's the height of the person in inches. Okay, I'm 75 inches tall. Interesting. Okay, so f of 75 is 0.92 times 75 plus 2. And what we get, we want to evaluate that, we end up with 71. So we've got two numbers here, the input 75 and the output 71. 75 corresponds to the height of the person. 71, smaller number, represents the output, which is the height or the length of the crutches. So which of these, A, B, C, or D, is correct? A person 75 inches tall needs crutches that are approximately 71 inches long. Notice B is incorrect. It has them reversed. Okay? And think about it. How could you have a person 71 inches tall with crutches 75 inches high? That would be hard. Right? And so B is not right. C is ridiculous. Okay? D is also not correct. Okay? So A is the correct answer. Remember what your input is, remember what your output is, and you should be fine. Okay? So interpretation is important. There are some interpretation problems later in the review. We'll get to those. Okay. All right, number 17, we look at a graph. Okay, looking at a graph, all we want to know is which of the following lines have negative slope. Okay, negative slope means we slope from upper left to lower right. Okay, we're sloping down, okay, going down as we move from left to right. Positive slope is something like in number 2, where the function is increasing as we move from left to right. So which of the following lines have negative slope? Number 1? Yes. Yep. Number 2? No, that's positive slope. What about number 3? What kind of slope is that? It's not negative. It's not positive. It's a vertical line. And what type of slope do we have when we have a vertical line? Undefined slope. Undefined slope. What type of lines have zero slope? Horizontal lines. All right, horizontal lines. Okay. Someone once said a straight line. Well, all lines are straight. Right? Okay. So not 3, but 4. That's a negative sloping line as well. Okay. So we have a line like this. That's positive slope. We have a line like this. That's negative slope. We have a line like that, horizontal. That's zero slope. We have a line like that. That's undefined slope. Okay. Horizontal line have zero slope. Vertical lines have undefined slope. Okay. All right, now we're given a line, 2x minus 3y minus 3 equals 0, and we have to find the slope and the y-intercept. Okay? So, all right, let's see. Several ways to do this. One thing we can do is take this equation and write it in slope-intercept form. Slope-intercept form is nice. Slope-intercept form is of the form y equals mx plus b, where m is the slope and b is the y-intercept. Then we could just read off the slope and read off the y-intercept. In other words, take this equation and solve it for y. That's one way to solve this problem. So what we can do is solve this for y. So get all the terms that don't have y, bring them to the right. Okay. So by doing that, I would get negative 3y equals minus 2x plus 3. Notice what I did here. I subtracted 2x from both sides. I also added 3 to both sides. And so I get that. And then I will divide everything through by negative 3 so as to get y by itself on the left. When I do that, I do get y by itself on the left. And I have, well, the negative 2 and negative 3, the negatives cancel, and I have 2/3 x And then 3 divided by negative 3 is negative 1. And so 2/3 is my slope, and negative 1 is my y-intercept. Okay, so there we go. We've got it. All right. It's going to be very helpful to take an equation of a line and put it in slope-intercept form. Okay, so get used to doing that. Okay, it's going to be very helpful. Okay. In fact, if we look at number 19 here, I think it's going to be helpful to take that line. Okay, 4x minus 5y equals 20. Let's take that line and put it in slope-intercept form. Let's do that right away. So if I take this, I'm going to solve it for y. Okay? So when I solve it for y, the first thing I will get, I want to only keep the negative 5y on the left. So I'll subtract 4x from both sides. And I already have the plus 20 on the right. So I've got negative 5y equals negative 4x plus 20. And now to do, or what should we do to get y by itself? Good. Divide by negative 5. All right. And so let's see. We have y equals 4/5 x minus 4. Negative 4 and negative 5, the negatives cancel, so I have 4/5. 20 divided by negative 5 is negative 4. So what's my slope? 4 over 5. And what's negative 4? That's my y-intercept. Okay. So this graph passes through the point 0, negative 4 on the y-axis. Okay. Well, let's see. It says, which of the following is not true? Okay. It rises from left to right. Well, this slope is negative, slope is 4/5, positive. So a positive sloping line slopes like that. It rises from left to right. So that's true. Okay. This statement is true. We want to pick out what's not true. Okay. It has y-intercept negative 4. Is that true? Yeah, that's true. We just found that out. So that's true. It passes through the point 10, 4. Okay. Well, we can see if that's true. 10 would be our x. 4 would be our y. Okay. So if we plug in x equals 10 and y equals 4 into here and get a true statement, then we know that the line passes through that point 10, 4. So let's try it. Let's take this line and let's look at x equals 10, y equals 4. So 4 times 10 minus 5 times 4 equals 20. The question is that true? That's true. 40 minus 20 is 20. So this is true. All right, we're getting there. It has slope 5/4. Ooh, that's the false one. It has slope 4/5. Okay, so that is the correct answer because it's false. Okay. And it has x-intercept 5. That is true. It does have x-intercept 5. By plugging in the point 5, 0 up here, you get a true statement. Okay. 20 minus 0 is equal to 20. Okay. I'll show you that. The point 5, 0. That statement is true. 20 minus 0 is 20. So not only is 10, 4 on the graph, but also 5, 0. And because of the y-intercept, 0, negative 4 is also on the graph. So we know a bunch of points on the graph of this line. Okay, so the correct answer is D. That's the only one that's false. All right. For number 20, there are actually two ways of solving this problem. Okay. One way is to do something that we did before. In other words, take the line there and put it in slope-intercept form. Okay. And if you do that, you'll get the slope and the y-intercept. Okay. Pretty easy. This is called the standard form. Okay. Standard form, where you see x and y on the same side. Okay. And if you see x and y on the same side, there's another way to find the slope very easy. Okay. If the coefficient of x is what you are calling a, and the coefficient of y is what you will call b, then the slope is simply going to be negative a over b. That's a really easy way of finding the slope. Okay? And so in this case, what would our slope be? Negative 3 over 5. Done. Okay? Now, if you had taken this and put it in slope-intercept form, we could do it. Now let's do it. That's the first step. All right? Let's take this and put it in slope-intercept form. Move the 3x over to the right. Move the 1 over to the right. Make them negative 3x and negative 1. Divide both sides by 5. And you get y is equal to negative 3/5 x minus 1/5. So here you also get, for free, the y-intercept. We didn't need that for this problem. But you see the slope is negative a over b. Okay? Negative 3/5. So that might be a shortcut for you if you want to use that, if you're just asked to find the slope. In number 21, we're also asked to find the slope, but here we're given 2 points. This is going to require you to remember the slope formula, which you have on your formula sheet. All right, so here we have 2 points. Can you see that okay? All right. x1, y1, and x2, y2. Okay. So here, our slope is going to be given by rise over run. In other words, the difference in the y values divided by the difference in the x values. y2 minus y1 divided by x2 minus x1. Just really watch your signs here. Be careful. y2 minus y1 is 3 minus 1. That wasn't so hard. And then x2 minus x1 is 2 minus negative 3. And so we end up with 2 on the top. And what do we have on the bottom? 5 on the bottom. Okay. And so 2/5 positive C is our answer. Okay. Remember the slope formula, and that'll get you home. Okay. For number 22, notice you're not asked to do much in 22, but you have to know something about perpendicular lines. Okay. The slope of a line which is perpendicular to this given line, all right, is what? So what is the slope? Now, what is the slope of this line here? Negative 2. Okay, that's the slope of this line. Okay. If we have 2 lines that are perpendicular, what do we know about their slopes?
They're opposites.
They are reciprocal and negative. So negative reciprocals of each other. Okay. So if you have the slope of a given line, negative 2, you find the negative reciprocal of that. Now, negative 2 is negative 2 over 1. So what we do to find the negative reciprocal is find the negative of it and find the reciprocal. So flip and change the sign. Okay? So we flip this and change the sign, and we get 1 over 2, which is B. Okay. Now, if this did not say perpendicular, but rather said parallel, okay, then the slopes of the 2 lines would be equal, and the correct answer would be C. Okay? But it says perpendicular. Okay? Another way to think about perpendicular lines, their slopes multiply to negative 1. Okay? The slopes of perpendicular lines multiply to negative 1. Negative 2 times 1/2 is negative 1. Okay? That's another way to think about finding slopes of perpendicular lines. Okay? Questions about that? It's more of a concept question, nothing really to work out. All right, for number 23, here we have 2 points given, and we have to find the equation of a line. Okay. There's a very nice formula called the point-slope formula that helps us find the equation of a line. And that formula looks like this: y equals m times x minus x1 plus y1. Or sometimes you'll see it as y minus y1 equals m times x minus x1, where m is the slope and x1 and y1 are the coordinates of a point on the line. So just by given 1 point and the slope of the line, we can find the equation of the line. Well, here we're given 2 points on the line. Okay? However, we just saw in the last problem that we can use 2 points on a line to find the slope of the line. And then we'll use that slope together with just one of these points and find our equation. All right, so even before we start the problem, we think about how we're going to do it. So let's first find the slope. The slope is going to be the difference of the x's, the difference in the y's, 3 minus -1, divided by the difference in the x's, -1 minus 1. And so 3 minus a -1 is 3 plus 1, or 4. And -1 minus 1 is -2. So our slope is -2. Okay. Now right away, when I see the slope is -2, what answer choices can I rule out or eliminate? I can throw out A, I can throw out B, and I can throw out E. Darn it, I still have 2 left over. Too bad I couldn't just narrow it down to 1. I still have to do some more work. It's either going to be C or D, right? Because those are the only 2 that have slope -2. All right, so now I have to do some work with the point slope formula. So let's choose one of these points. Let's just choose that one. You can choose any one you want. -1, 3. I use my point slope formula. I have y equals our slope, -2, times x minus -1 plus y1, where x1 was -1 and y1 was 3. Okay? Just be careful, inside here, this is x plus 1. So I have -2x minus 2 plus 3. So I have -2x plus 1. If I did everything correct, my answer, D. Is that right? Okay. Notice a close answer, -2x minus 1, the incorrect answer. Okay. 24, we're not going to go over, but it's just like 23. All right. What they're giving you are 2 points. The 2 points are the x-intercept, which is -2, 0, and the y-intercept, which is 0, 3. So now armed with those 2 points, find the slope of the line, and then use the point slope formula together with one of those points and the slope, and you get the equation of the line. Okay, so nothing really spectacular there. Okay. All right, moving along, 25. Okay. Which of the following is the equation of the line passing through the point -1, 3 and perpendicular to the line 3x minus 2y equals -2? All right. Now, let's see if we can work this problem out. We have perpendicular. So remember, we're looking for a line that is perpendicular to this one. Okay. So let's find the slope of this line. Okay. This is written in standard form. We could write this in slope-intercept form and then find the slope, and it would be right there. Okay. Or, remembering that the slope, what did we just learn? The slope is equal to -a over b, or -3 over 2. Okay. So the coefficient of x, that's a, and the coefficient of y is b. Okay. So the slope is -a over b, or -3/2. Okay. All right, so now we have the slope as being -3 over 2. We want perpendicular. Okay. So our line is going to have what slope? Positive 2/3. Yeah. All right. Negative reciprocal of -3/2. Okay. So 2/3. All right. And it also has to pass through the point -1, 3. So now we can use our point slope formula. Y equals m times x minus x1 plus y1, or y equals 2/3 times x minus -1 plus y1. Okay. All right, and so what do we have here? We've got y equals 2/3 times x plus 1 plus 3. Okay. And simplifying that, we have y equals 2/3 x plus 2/3 plus 3. Okay. Or y equals 2/3 x plus 3 2/3 or 11 thirds. Okay. Now, we don't see that as one of the answer choices, do we? Our answer choices are listed in standard form, not in slope-intercept form. All right, so what we can do to get this in standard form is to do what? We've got to get rid of those fractions. Multiply all sides by 3. Right? So we have 3y equals 2x plus 11. Okay? And we're getting closer and closer. It looks like we're going to get answer choice 2x equals, I'm sorry, 2x minus 3y equals negative 11. So that's choice C. You just have to work with these equations sometime. They might not be in the right form. Okay? So 2x minus 3y equals negative 11. That's the correct answer. All right, 26. Okay. For number 26, let's take a look at this one really quickly, because here we have to figure out which of the following is true. Okay, is true. So now we're looking for the true one. All right. We look at these two equations. One is standard form. One is slope-intercept form. Let's get both of these in slope-intercept form. So let's go down and write this equation in slope-intercept form. Slope-intercept form, I have 2y equals minus x plus 5. Okay. And dividing both sides by 2, I get y equals negative 1/2 x plus 5/2. So that's one of the lines. And the other line is already in slope-intercept form. Okay. So what do you notice about these two lines? They have the same slope. I also heard someone say they're parallel, and that's correct. Okay. And so, whoa, okay. Looks like the lines are parallel. Okay. Now, there was an answer choice that said the lines are the same. Okay. And if the lines had the same slope and the same y-intercept, then they'd lie on top of each other and be exactly the same. Okay. But here, the y-intercepts are different. 5/2 and 1 are different numbers. So the lines are parallel. They're not exactly the same, but they have the same slope. Okay? And the other choices are incorrect. Okay. Number 27, we're going to skip that one because we've done stuff like this. We're given the slope, we're given a point. Find the equation of the line, use the point slope formula. Okay, so we've done something like that. We'll move on to bigger and better things. Okay? Like 28. 28 is one of these concept questions. Okay? Determine whether the table here is linear or nonlinear. Is the data linear or non-linear? Well, what do you think? Nonlinear. All right, well, let's see why. If it's going to be linear, that means that as x increases by a constant amount, if the table is linear, then y should increase by a constant amount. Not necessarily the same as x, but by a constant amount. So here, notice x is increasing by how much each time? 1. Okay. And so y should increase by the same amount each time to be linear. Well, here from 35 to 40, that's an increase of 5. From 40 to 45, that's an increase of 5. From 45 to 52, that's not an increase of 5. That's an increase of 7. So this function is not a linear function, so non-linear. Okay. If you were to graph these 4 points, right, 535, 640, 745, 852, they would not lie in a line. Okay? But don't bother doing that. That takes too long to do. You've got to set up your axes. You've got to plot points. Just remember how to tell a linear function from data, or a nonlinear function. Okay? Speaking of functions, here's a nice interpretation question. Okay? The correct dosage of a drug is 50 milligrams plus 2 milligrams for each pound the patient weighs. So the 50 milligrams, think of that as a fixed amount, okay? And then the 2 milligrams, we think of that as a variable amount. That amount is dependent on how much the patient weighs. Okay? So we're going to have a function, and that function is y Y is the correct dosage for a patient weighing X pounds. So given the weight of a person, we will determine Y, the correct dosage in milligrams. So again, we got to keep track of what X is and what Y is. Okay? So let's write a formula for this function. So Y is going to be the dosage, and Y depends upon two things. Well, we've got the 50 milligrams that's fixed. Okay? That's fixed. And then the 2 milligrams is for each pound the patient weighs. And so if we have 2, the 2 should be multiplied by the weight of the patient. Right? 2 milligrams for every pound the patient weighs, so X pounds. And then this 50 is an additional dosage that has to be given no matter what you weigh. Right? So that's a fixed amount. And so Y equals 2X plus 50, right there, D. Okay. The others, notice there's 2 and there's 50, but they're all mixed up in different ways, and so you pick out the correct one. Number 30 is a lot like this. Oh, and in fact, what is the slope here? 2. The slope is 2, not 2x, but 2. The slope is a number. And that means that for every additional pound that the person weighs, that's 2 more milligrams that the drug, 2 more milligrams of the drug. Okay? So that's another way to remember that the 2 goes with the x. Okay. All right, number 30, we've got a car. It starts off costing $22,000. It decreases in value. You know that's true whenever you have a car. All right, as time passes, the value of the car depreciates. Okay? And it loses $300 each month. Let V be the resale value after T months. So T is kind of like the X here. T is like the input. And so we've got a car that starts off at $22,000. So that is the fixed or initial amount. Okay? And the car loses $300 each month. Okay? So we're talking about a decrease, all right, a constant decrease of $300 for each additional month. All right? So as time passes, the car loses value, and that's indicated by this function V. Okay? 22,000 minus 300t, where minus 300, that's going to be our slope. Each month, car value decreases by $300, or is $300 less than the previous month. So notice when t is equal to 0, V is equal to 22,000. A brand new car, right? Time hasn't passed. Brand new car is worth 22,000. Okay. All right, here's a cute little problem because it deals with a cute little baby elephant. We've got this baby elephant, and the weight of the elephant Y in pounds. Okay, so remember what Y represents. For a healthy baby elephant that is X months old, so X represents the age of the elephant in months, Y represents the weight of the elephant, is given by this function. Okay? Interpret the meaning of the expression f of 2. Do not evaluate. Okay, we won't evaluate it. Okay, but let's think about what it means. Okay? F of 2. Now 2 is the X. Okay? And what does X represent? The age of the elephant in months, how many months old the elephant is. So f of 2, okay, 2 means the elephant is 2 months old, and when we evaluate f of 2 is going to be the weight of the elephant that's 2 months old. Okay? So the weight of a 2-month-old elephant. That's a nice way to interpret f of 2. It's the weight of a 2-month-old elephant. Now, we won't know what that is until we evaluate f of 2. But they say don't evaluate it, so I won't do it. Find the y-intercept of this line. What is the y-intercept of that function? Good. Y-intercept is 250. Okay. Now, the y-intercept is what we get when we set x equal to what?
0.
0. Okay. So when x is 0, that means the baby elephant is 0 months old, so that means just born. Okay. And so what does that mean in terms of the weight of the elephant? Yeah, a typical baby elephant is 250 pounds at birth. That's a nice way to interpret that. Okay? This is equal to f of 0, by the way, right? When x is 0, y is 250. That's the y-intercept when x is 0. Find the slope of this line and interpret its meaning. What's the slope of the line here? 60. Okay? Slope is a rate of change. Okay? For each additional value of x, y increases by 60. In terms of this problem, that means for each additional month of life, okay, the baby elephant gains 60 pounds. So it's 60 pounds heavier. All right? So on average, a typical baby elephant will increase in weight by 60 pounds per month. That's a rate. Okay? That's a slope. We'll skip over number 32 because that's quite similar. Here it asks you to evaluate, or not evaluate, but interpret the function. Okay, so we'll skip over that one. Okay, notice it asks for the x-intercept. Okay, x-intercept is what you get when you set y equal to 0. Okay, and then you can interpret what that means, okay, in terms of this problem, and then also look at the slope. All right, let's talk a little bit about directly proportional. Okay, so proportion, we want to set up a proportion. So we have the cost of coffee is directly proportional to the amount of coffee purchased. Okay, 2.5 pounds of coffee costs $15. How many pounds of coffee can be bought with $12? All right, so we've got two things going on here. We've got the pounds of coffee and we've got the dollar amount. All right, so 2.5 pounds relates to $15. Okay? In much the same way that some mystery amount of coffee, X pounds of coffee, corresponds to $12. And so we set up this simple proportion, and once we've got this simple proportion, we get all these words that are now translated into this easy to solve equation. And how do we solve a proportion for X? Right? Cross multiply and solve for X. So here, multiply 2.5 times 12, and we get 30. So 2.5 times 12 is equal to what we get when we take 15 times X. 2.5 times 12 is 30, right? And then 30 is equal to 15x, and x must therefore be equal to 30 over 15, which is 2. So how many pounds of coffee can be purchased with $12? 2 pounds. Okay, 2 pounds. All right. And you can look at this and check your answer. Okay. Clearly your answer should be less than 2.5 because you're not spending as much money. Okay. So if you've gotten an answer of, say, 4 or 5, right away you should say, oh my gosh, no, that can't be right. Right. So check your answer, at least make sure it makes sense, and then you can move on. Okay. For inversely proportional, okay, it's kind of the reverse. Okay. Here's an easy way to think about inverse proportion. All right. See how x changes, and then y is going to change inversely, right, the inverse. And proportion always deals with multiplication and division, not addition or subtraction. So here, notice we have y is equal to 16 when x is equal to 3. Okay. Now x has suddenly gone up to 6. Okay. Now thinking about multiplication or division, what has happened for x to move from 3 to 6? Doubled, yeah, or multiplied by 2. Okay. And so what has to happen to y? Well, what's the opposite of doubling something? Halving it. Right? The opposite of multiplying by 2 is dividing by 2. So if y is inversely proportional, not directly proportional, but inversely proportional to x, then when x doubles, y is being halved. And so what's my correct answer? B. Okay? B. Notice that A was put there to trick you. Because someone will come along and say, oh, okay, x doubles, so y doubles. And you'd be wrong, right? So that's a trick, yeah. But you won't be tricked on when it's for real, right? Okay? You will not be tricked for real. Okay? It's okay to make mistakes now. Right? We can correct them. All right, let's look at 35. I've got about 25 minutes left with you before Dr. Quander takes over. And I want to go through probably problem 48 or so, through 48, and then she'll take over from there. So looking here at number 35, here we have an inequality. So let's solve some inequalities. Okay? Key thing to remember with inequalities. Okay? Kind of like equations, you do the same thing on both sides of the inequality. Okay? But if you multiply or divide by a negative expression, you have to flip the symbol. Yeah. All right? If you multiply or divide by a negative, you got to flip the symbol. All right? So let's see if we ever see that happening here. So we've got negative 5x greater than negative 3x plus 4. I want to get all the x terms on one side, doesn't matter which one, and then all the numbers on the other side. So I'm going to add 3x to both sides here. And so does that change the symbol?
No.
No, adding never changes. Subtraction never changes it either. Okay. So I have minus 2x greater than 4. What am I going to do to both sides now to get x by itself? Divide by negative 2, and that is going to give me x less than negative 2. Yeah, the symbol has flipped. Okay, now if I look at my answers, I don't see x less than negative 2. I see my answers in interval notation. So x less than negative 2, I like to draw a little number line here, plot negative 2 on the number line, and then shade what I'm interested in. I'm interested in x strictly less than, not equal to, less than negative 2. So everything to the left of negative 2, as an interval, that's negative infinity to negative 2 with parentheses, not brackets. Bracket would be if I was including negative 2 as an answer. If this were less than or equal to negative 2, then I'd have a bracket on the negative 2. But I don't, and they didn't even try to trick me by putting a bracket there. So D is the correct answer for number 35. No, it's not. I was tricked because I was careless. E is the correct answer. Thank you for saving me. Okay. All right. 36, I'm going to jump and do number 2 because it's got a fraction. All right, and we'll see what to do to deal with those fractions. 36, number 1, I think you're pretty comfortable doing that one. It's just like the one we did before. Again, just remember, dividing or multiplying by a negative switches the symbol. Okay, that's the key. All right, now number 2, I've got a fraction here. I want to get x by itself, but I've got a fraction. And we want to get rid of fractions as quickly as possible. So what can I do to both sides of this inequality to get rid of the fraction? Multiply by 5. And if you do it on one side, you have to do it on the other. Golden rule of algebra, right? Golden rule, do unto one side as you would do unto the other side. Okay. So when I look at the left side, the 5's cancel, and I have x plus 1 less than or equal to, because I didn't multiply by a negative. Oops, I should bring that up. And when I multiply here, I have to distribute the 5, so I have 5x minus 15. And now we've got something similar to what we've seen before. We just have to gather the x's on one side. And so why don't I subtract x from both sides here? Okay, when I do that, I have 1 less than or equal to 4x minus 15. Notice the symbol remains the same. All I did was subtract a number. Okay. And now what am I going to do to both sides? I'll add 15 to both sides. Sure, that'll help. Because now I have only the terms that have x on the right side. So I've got 16 less than or equal to 4x. Divide both sides by positive 4. And I have 4 less than or equal to x. Another way to write this is x greater than or equal to 4. Okay? And they want us to graph the solution set and write the answer in interval notation. This is inequality notation here. X greater than or equal to 4. Number line would be how to graph it. Greater than or equal to 4 includes 4 and everything to the right. Okay? And what would the interval notation look like? Bracket here, or always put a parenthesis on infinity or negative infinity. But since we're including 4 as an answer, 4 gets a bracket. Okay. X greater than or equal to 4, otherwise written as the interval from 4 to infinity. Okay. Great.
Now it says graph the solution set.
That's this number line here.
Number line.
Yeah, that's the graphing the solution set. So I shade what is solution. Right.
So assume that y is equal to 0, or that they're equal.
Yeah, we're only solving for x here, so there is no y.
Right.
Yeah. All right, let me do one more of these with you. Compound inequality. All right. Compound inequality's got 3 parts, a left, a middle, and a right. And the goal is to get x by itself in the middle. Get x by itself in the middle with nothing else in the middle. All right, now I've got a pesky fraction here again, so what can I do to now all three parts of the inequality? Multiply by 5. And if you had multiple fractions with different denominators, you would multiply by the lowest common denominator. Right? Just like you do when you add fractions and things like that. You find the lowest common denominator. Multiply by a number that will get rid of all the fractions. Okay? So here, multiply first by 5. All right, so when I multiply the left by 5, I get negative 5. Symbol is still less than or equal to because I haven't multiplied by a negative number. I multiplied by positive 5. Now, when I multiply the middle by 5, the 5 cancels with the 5 in the denominator, leaving me with 3 minus x. And then when I multiply 3 by 5, I get 15. So there's my new and nicer looking, I think, inequality. Okay. Now I want to get x by itself, so what can I do next to start to do that? Subtract 3 or add negative 3. Okay. So subtract 3 from all three parts. That doesn't change my symbols. They're still like that. Negative 5 minus 3?
Negative 8.
Negative 8. In the middle I have minus x. And on the right I have 12. Okay. I want to get x by itself. I have negative x. What do I have to do now? Divide through by negative 1, which will or will not flip my symbols?
Will.
Oh yeah, it'll flip them. Right? So now I have flipped symbols, and I have x in the middle. On the left side, I have positive 8. On the right side, I have negative 12. Negative 12 is the smaller number of the two, right? Negative 12 is smaller than 8. And so another way of writing this is from left to right, negative 12 less than or equal to x less than or equal to 8. Okay? As a number line, all right, now we've got two values here, negative 12 and positive 8. Okay, make sure that you graph them in the right order. And we've got less than or equal to, so we're including those. I'll put closed circles here. And x is everything in between plus those endpoints. Okay. So there's my solution set graphed. But now we have to write the interval notation. Here's the inequality notation. There's the number line. And now I'm interested in everything between negative 12 and 8, including them. Brackets on both numbers. Okay. Brackets on both. Whenever you see a non-strict inequality like this, less than or equal to, or greater than or equal to, bracket. Okay. If it's a strict inequality, like strictly greater than, strictly less than, parenthesis, because you're not including that number as part of your solution. All right, we got to move. Okay. Let's evaluate some piecewise defined functions here. Okay. In fact, I will do number 38 with you and then leave you to look at number 39 because it's the same concept. Here we've got evaluate f of 1. Here's our function. It's a piecewise defined function. The key thing to look at here is what happens after the word if, because that's your domain. All right? You have to look at the x value. Okay? Here the x value is x equals 1. And if you want to evaluate f of 1, you have to figure out which piece, if any, do you use, the first piece or the second piece. Now, 1 is a number that is greater than or equal to 0. Right? 1 is bigger than 0. So we're going to use the first piece here to evaluate, and that's where we plug in 1 for x. So f of 1 is going to be the square root of 1 plus 3, which is the square root of 4, which is 2, which is choice D. Okay. If you used x in the wrong piece, you would have gotten 1 squared minus 1 is 0 and chosen A, and you would have been wrong. Right? So do not use the second piece, use the first piece. 1 is greater than or equal to 0, hence use the first piece. Now with 39, just look at the value of x and think about which, if any, piece you're going to use. Okay? So to evaluate, you're only going to use one piece. You can only use one piece when you evaluate a piecewise defined function. So for f of negative 3, which piece would you use? Piece 1 or piece 2? Piece 2. Negative 3 is less than 0, so you'd use piece 2, second piece. For f of 0, 0 is greater than or equal to 0, so you would use the first piece. And for f of 6, you would use which piece? First piece. Okay. And so then just plug in to that appropriate piece. So determine which piece to use and then plug in. You only should get one answer. Okay. All right, let's look at number 40. All right, the graph of a function f is shown here. Now look, we're only given the graph. We're not given the formula for the function. And we want to use the graph to determine where is f of x positive. Okay? So we're looking for values of x, okay, for which the graph is strictly above the x-axis. So we're looking for above the x-axis. In other words, where is y positive? Okay? Well, looking here, where is y strictly positive? Well, I see it's positive here, and I see it's positive here for these values of x. I've shaded values of x on the x-axis that produce points on the graph that are above the x-axis. And so in other words, I've outlined here the points from negative 3.5 to 0 together with 3.5 to infinity. And notice I used parentheses and not brackets. Was I correct there?
Yes.
Yeah, right? We used parentheses because it's a strict inequality. It didn't say greater than or equal to 0. So don't include the x-intercepts. Don't include the endpoints here. Okay? Don't include those 3 x-intercepts as part of your solution. Okay? So that's negative 3.5 to 0 together with, or with union symbol, 3.5 to infinity. The answer are x values. Okay. So now, where is f of x less than or equal to 0? Well, here we're looking for where we've got the graph below the x-axis or on the x-axis because it's less than or equal to 0. Okay? So where's that going to be? That is, well, anything here, including here, and then from here to here, including the endpoints in red. Okay? So from negative infinity to negative 3.5, including negative 3.5, okay, together with from 0 to 3.5, including both of those numbers. Okay? Negative 3.5, 0, and 3.5 are the x-intercepts, and those are the values of x for which the function evaluates to 0, y equals 0. In fact, isn't that the question 41? Right? For which values of x is f of x equal to 0? Well, precisely the x-intercepts. Okay? The x-intercepts are negative 3.5, 0, and 3.5. So pick out the x-intercepts. They're also known as the zeros of the function. That's another way of asking this question. Find all zeros of the function. Those are the values of x that evaluate to 0. Okay. All right, number 42 should not take us very long to solve. In fact, we have a graph, and we're asked to use this graph to approximate a solution to the following equation. Well, notice that the left-hand side of that equation is just that function graphed. Okay? So we want to know a value of x for which this function evaluates to 0. Well, we just said that that's finding the x-intercepts. Okay? And so this function has how many x-intercepts? 2. It's got one right there, and it's got one right there. Okay? And so we're used to approximate a solution. So it's a good thing they gave us some answers here, answer choices. Okay? Which of these is an approximation of a solution or an approximation of the x-intercept? What do you think?
C.
C. Looks like C. 1.4, which is probably this one right there. Okay. The other one's negative 0.75. That's somewhere over here. No, right? 0 is here. No, that's not an x-intercept. Negative 2 is way over here. That's not an x-intercept. And 2 is over here. That's not an x-intercept either. Okay, so the key is when you see function equals 0, you're looking for the x-intercept. Okay. All right, number 43. Okay. Absolute value inequalities. Absolute value inequalities. Absolute value inequalities involve solving absolute value equations. Right? These are absolute value equations. Absolute value equations involve solving two equations. Okay? Because in order for the absolute value of something to be equal to 2, okay, that something inside could be one of two things. It could be 2, and then the absolute value of 2 is 2. Or this 5x minus 7 could be what? It could be negative 2, and then the absolute value of that negative 2 would give you 2. Okay? So there are two possibilities. Either 5x minus 7 is equal to 2, or 5x minus 7 is equal to negative 2. In both cases, when you take the absolute value of 5x minus 7, you get 2. Okay? So we have to solve both of these, and we'll solve them independently, and then it says find the sum of the two solutions. So you may be asked to do this on the final exam. Solve an absolute value equation. You get two answers. Add the two up, and that's your answer. Okay. So let's see. We have 5x minus 7 equals 2. Let's add 7 to both sides, and we get 5x equals 9. Dividing both sides by 5, x is equal to 9/5. Over here, again, we can add 7 to both sides. We get 5x equals, what's negative 2 plus 7? Positive 5. Right? And divide both sides by 5, and we get x equals 1. So we have x equals 1 and x equals 9/5, but then it says find the sum of the two solutions, and that sum is what we should look for in our list of answer choices. Now, if we had a list of answer choices here, you will have one. Okay? So 9/5 plus 1 is 9/5 plus 5/5, which is 14 over 5. That's what you should look for in your answers. Okay? So again, you'll have to do that. You'll have to find the two solutions, and then it'll tell you to add them up and give the correct answer. We're going to skip number 44 because not all of you have studied absolute value inequalities, and you will not see them on the exam. So we'll just skip right over that one. All right, I've got about 5 more minutes with you, and so we'll take a look at just a couple more problems, and then Dr. Quander will take over. Here we have a parabola. We know it's a parabola, or we know it's the function or an equation of something that, when graphed, is a parabola because it's a quadratic equation. Okay? A parabola is a U-shaped curve that either opens up or opens down. The sign of the coefficient of x squared, if that number is positive, the parabola opens upward. If this number is negative, the parabola opens downward. So we know this parabola opens upward like that. And we have to find the location of this point, which is called the vertex. Okay, when a parabola opens upward, the vertex is the valley point or minimum point. And here, if we look at a quadratic equation, the value of a is the coefficient of x squared, the value of b is the coefficient of x, and the value of c is the coefficient of 7. You'll use those a, b, and c values if you ever have to solve a quadratic equation, which you will do later in this review. Okay. But for the vertex is at coordinates negative b over 2a, f of negative b over 2a, where f is this function here. Okay. So find negative b over 2a, that's the x-coordinate of the vertex, then take that and plug that value in for x to find the y value of the vertex. So negative b over 2a is going to be negative 8, just watch your signs here, over 2 times 4, which is 8. So negative 1. So the vertex has x-coordinate negative 1, so I know the answer is not A, not B, not E. Again, it's either C or D. Okay. And now what I'm going to do is evaluate f of negative 1. In other words, I'll take negative 1, plug it back in here for x. So I have 4 times negative 1 squared plus 8 times negative 1 plus 7. Let's see, negative 1 squared is 1. 1 times 4 is 4. Minus 8 plus 7, is that 3?
Yes.
Negative 4 plus 7, 3. Negative 4 plus 8, negative 4 minus 8 plus 7 is 3. And so my correct answer is right up there, C. So we find the vertex. Okay. X-intercepts of a parabola. All right. Well, we talked about x-intercepts. X-intercepts are values of x for which y is equal to what? 0. Okay. So when is y equal to 0? Well, y is equal to 0 when we set it equal to 0. And we have to solve x squared plus 8x plus 7 equals 0. It's as easy as that. We just have to solve that for x. We can solve that for x by using either quadratic formula if we wanted to, which you'll have to remember for the exam. Or maybe we can factor. All right? How does this factor?
Set x plus 7 and x plus 1.
X plus 7, x plus 1. Then set each of the factors equal to 0. So we get x equals minus 7 and x equals minus 1. And answer C. Okay. Okay, just 2 more with you. Well, for number 47, let me just talk about 47 for a minute. 47, which of the following is true? And only one of these statements is true. Okay. What we have to do is first look at the function there. We know it's a quadratic function, so we know its graph is a parabola. Okay. And look at the answer choices. It talks about the vertex, and it talks about the opening, up or down. Okay. Now, if I look at this parabola, notice that the coefficient of x squared, the leading coefficient, is negative. What does that mean in terms of how the parabola opens? Down. All right, so right away, C is wrong, D is wrong. Okay. And so it's either going to have vertex negative 1, negative 5, 1, 3, or 2, 5. Okay. And to find the vertex, remember, we start off by taking negative b over 2a. A here is equal to negative 2. B is equal to 4. C is equal to 1. So negative b over 2a is negative 4 over negative 4, which is 1. Notice that in this example, we don't even have to find the y-coordinate of the vertex. The only one that has x-coordinate 1 is b. Right? So multiple choice test, boom. We didn't put another answer that had x equals 1, so that's the only one. Okay. And then finally here, the last one that I'll do with you. Which of the following graphs represents the function y equals negative x squared plus 4x plus 2? Okay. 2 things that I would look at here. First of all, look at the leading coefficient. It's negative, so that means the parabola opens down. A can't be, B can't be. All right. And then look at 2 here. 2 is the y-intercept, and the only one that has a y-intercept of 2 is C. So it's not D, and chances are it's not going to be none of these. Okay. You can also check the vertex, and you'll see the vertex lies right here at 2, 6, and if you check that, you'll indeed see that's the case. Okay? It's been a pleasure working with you. Dr. Quander will take over through the second